Hey guys, welcome back to Hustler's Algorithm. In this video, we would be solving this problem all paths from source to target. So this is basically a graph based problem, and here we are given a directed acyclic graph of n nodes which are labeled from 0 to n minus 1, and we have to find all the possible paths from the node 0, which is the first node, to the n minus 1th node, which is the last node, and we can return the answer in any order. The answer would be the paths, and the graph is given as follows. Like, the graph of ith element represents that there is an edge from I to the elements which are present at that ith position. So to be more precise, here at 0th position we are given an array of 1 and 2. So this simply means that from 0 we can go to 1 and we can go to 2. So yeah, this is the same for all the indices. So let's get started. So this is our graph. Now what we can do is we can simply run a DFS from the starting node, which is 0, and we will traverse all its adjacent nodes, and we will keep doing this recursively till we encounter 3, which is the ending position of our path. So when we reach at 3, we will simply take the path which is there from 0 to this ending node into our answer. Let's say we follow this path to reach 3, then we will add 0, 1, 3 in our answer because this is one path. So yeah, we will keep doing this. Now let's see this in action. Okay, so we will start from this 0, hence we will add this into our current path. So let's add 0. Now we will go to its adjacent node, which is 1. We can either go to 2 or 1. Let's follow 1. Okay, so we will add 1. Then from 1 we will go to its connected node, which is 3. Let's add 3. Now at this point we can see that this is our ending node, so we can simply add this complete path into our answer. Let's say we have a global answer here, so we are having 1 as 0, 1 and 3. So this is our one path. Now let's return from here, and while returning we will just simply remove this 3. Now we'll go to 1 again. Now from 1 we do not have any unvisited node, so let's return back, and again while returning we will remove this 1. So we have only 0 till this point. Now from 0 we are having a node which is unvisited, which is 2. So let's visit this. So add 2 in our temporary answer, which is the current path. So now from 2 let's go to its connected node, which is 3. Let's add this into our current path. So now at this point we can see that this is the ending node, so we can simply put this path into our answer, which is 0, 2 and 3. So yeah, this is one path again. So from 3 we'll return back, and while returning we will remove this 3 from our answer. Now again from 2 we do not have any of the unvisited node, so we will again return back. Now again remove 2, and now we are at 0, and we can see that there is no unvisited node, so we will stop our DFS call. So yeah, this is our answer. So let's see, 0, 1, 3, this is the one path, and 0, 2, 3, this is the another path. So yeah, this is how we solve this problem. Now let's see this in code. So this is the actual code for our problem. First we will create a list of integers. So this will store all the paths from the starting node to the ending node. So then we will create a temporary list, and this will contain the current path. So we will add 0 into our current path because 0 will always be there in any of the paths. Then let's start the DFS from node 0, and we'll give the graph as the input, and this is the current path, and this is the answer which will contain all the paths. So this is our DFS function. So we will check if the node is the last node. If this is so, then we will add the current path into the global answer. Now for all the adjacent paths, we will just traverse them and add them into the answer, which is the current path, and then we will run a DFS at this node, and then we will just simply remove this from the current path while returning. So yeah, this will give us the paths. Then at the end we can just simply return the answer. So this is the code. So thanks for watching. Subscribe to the channel for more such videos. Thank you.